bases are in the hecto. 100. The units cancel out, leaving your hecto, and what you have to do is take 7,000 and divide it by 100 once, and then divide it by 100 again. That's how they got the 27. So I don't remember where this is over here. I don't remember what the problem we were doing. Were we on the first one? Yeah, we did the first one. Okay, and that was what, 0.35? Yes. All right, and we were working on the second one? Yes or no? Yeah. Did we do the second one?
No. Pay attention.
Okay, so we're ready to do the second problem. Is that correct? Yeah. Now, what I want you guys to tell me, is this a one-step question or a two-step question? Okay, very good. How do you know it's a one-step question? Because this is a base, and when we go directly from a base to a unit. So what we're going to do, question number 2, we're going to take 950 grams. We're going to do for factor label methods, we're going to go to ratio. The base is what's given, so where does the base have to go in the factor label process? On the bottom, we want to find kilos, so kilos have to go on top. Now, let's go to your reference table and tell me how many grams does it take to make a kilo? 1,000. 1,000. So you're going to put 1,000 in one. The grams cancel, so it will leave us with the kilo that we want. And that means we're dividing by 1,000, and 950 divided by 1,000 is 0.950, because we're dividing in 3 decimal places. All right, how many steps is it going to take to do question number 3? How many steps is it going to take to do number 3?
I think it'll.
It is 2, and the reason why we know it's going to take 2 steps is what's not present in either one of these numbers. The base. So we got to take millimeters to go to the base, and then we got to use the base to go to the centimeters. Is that correct? All right, so we're going to start with question number 3, and we're given 275 millimeters. Now, the moment you're given millimeters, what does that tell us has to go on the bottom over here? Why does millimeters have to go on bottom? So it cancels out, and it's going to the base. How many millis does it take to make a meter? Look at your table. How many millis does it take to make a base? 1,001. Now we can take our base and go to the unit that it's asking for, which is centimeters. And how many centimeters does it take to make the base? Look at your paper, everybody, just tell me. How many centimeters does it take to make the base? 100. Millimeters are going to cancel out. Meters are going to cancel out. Is that going to leave my desired centimeters? Now, when there's zeros, take advantage of them. 2 zeros are going to cancel out 2 zeros. So what am I really dividing by? 10. So wouldn't that be 27.5? All right. Question number 4. How many steps is question number 4 going to take? Okay, how do you know it's only going to take 1 step? How do you know it's only going to take 1 step? Because liters is a base. All right. So we're going to start off in question number 4 with 1,000 liters. Since liters were given, where does liters have to go? On the bottom, we want to find kilos. The question isn't how many kilos make a liter. The question is how many liters does it take to make a kilo? Look at your table. I gave it to you. How many liters does it take to make a kilo? It takes 1,000. Well, this is really easy. What does 1,000 over 1,000 do? Cancel. What does liters over liters do? So what's it leave us with? 1 kiloliter. All right, you guys try number 5. How many steps is number 5 going to take? How many steps is number 5 going to take? And again, why do you know it's 1 step? Because liters is a base. All right, go ahead and do that one. see how you guys do. You don't have to do questions. You done both sides already? Have you done it? You understand it, maybe we'll come back. Yes. We have one and 1,000 down there. Because how many buildings, okay? But what I was saying is, you see the N, which looks like meters. Yeah, there, now you got it right. Now you have it right. Okay, but that's one. Yeah. I could tell you were like pondering the comments.
I was really confused when I told you.
Yeah. All right, what you guys find out is the answer to question number 5.
1 liter.
1. Very good. And why did that work? It worked because you had 1,000 milliliters, and if you're starting off with milliliters, you got to end with milliliters, go to liters. How many milliliters does it take to make a liter? 1. That's really simple. The thousands cancel, the milliliters cancel, it leaves us with 1 liter. All right, now go over to question number 6. How do you do question number 6? Is it a 2-stepper?
No.
No, it's a 1-step. How many steps is number 7? It's a 2-step. How many steps is number 8? It's a 2-step, very good. How many steps is number 9?
1.
Very good. It's 1 step. And how many steps are in number 10? 1. All right, what I would like you guys to do right now is take a few minutes. And if you haven't done this side, what do I like you to do right now? Do this side. If you have finished them and you understand them, you can work on the back. Now the back is including English units. You do not have to do question number 3 because I frankly did not look up how many pounds were in a gram or how many grams were in a pound. So you don't have to do that. I didn't look it up. Yeah, I didn't look it up. So don't worry about it. You can skip number 3. Obviously, I'm probably not going to be having another test. What's up? Okay, so basically what you're doing is you're using these ratios. Now remember, ratio means they're free. So if I give you 20 centimeters, I can give you the same. Okay, so what we're going to do is if you're doing question number 6, you guys start with where you're getting. So you always start, so right what you're doing, you always have to start with that. And the unit is actually where you're going to He's actually telling you what it is.
Typical
Now,
Paul luck.
ratio is nothing but a fraction. Is that over 1? That's a fraction. And you always put a times over a product. Now, what you're doing is you look at that unit. Whatever that unit is, you automatically say the number. No, I didn't say the number. What did I say was the number? The directions are not numbers. The directions are unit number. Every unit has to go to the base. So you have to choose. So what is the base? Now, find your base. Find your number. Oh, okay. So the base has got a value of 1, and then the other has a value of, so it's 1 over 1,000. Now, we actually scored. Oh, no, that's it. So we're done. So then you're going to take this number and divide it by. And the reason why I'm dividing is because these are the denominators. That's so long. Yeah. Well, what you're doing is this number times 1. This number 1 times. Yeah. Then you're just dividing. All right, let's try the next one. So this is our talk. It's a 2-step. No, it's easy. We're making a card. We're doing it 2 steps. Make yourself right. Okay, right. So right now you're getting 4. Okay. Then what automatically has to go up? Centimeters, and it always has to go to the base, and this time the base is meters. So here is what's the relationship between centimeters and the base.
Family Feud.
So the base is
A word that rhymes with
okay, now we have to
And he
get
said,
the base.
church.
But we don't want to take the base, we want to go to.
He said purse.
Milliliters.
Church. He said, church.
One second. Come on, focus. So whatever's on top has to be the one on bottom. So what's on top? And then you want to find the base. Yeah, what we're on top. That is the same thing. Base. That's it. Okay? Okay, yes, so you're skipping the base step. Remember, you go from centis to the base, and then the base, so this should be meters on top. And then. We're not even done. But if you meters on top, whatever's on top has to go on. And now what unit did you actually find?
Are we allowed to ask questions?
I will put your hand.
You can just come up here around, but it only works in this section, and it only works when you're given other volumes, grams, and then if I start doing things. So do it my way. You answer your question. But if you never know what it works when it's. So I respond to it. Yeah, now you got it. Just don't skip that step.
Mrs. Morgan?
Yes.
Are we allowed to do one in our head if we know how to do it?
The answer to your question is yes, but I can't grade your head. So on a test, can I draw on your head and see what your head did?
No, that's okay. I understand.
Okay, all right.
I don't think you want to call it.
All right. If you get A's for the front, are you welcome to flip it over and work on the back?
Oh. Don't care, I don't care.
It's all cleaned up.
I don't.
Talk to me out, St. Michelle, because that's who you are.
I know. I'm not strong.
But what's interesting is the gap, but they're still exactly the same. So the gap between the water and water is
Oh, yeah.
You know what I mean? Yes. As far as I know, I you did this one, you just made a fearless mistake. Okay, I'm going to only give you the answers to the first two, just to see if you're on track. And then you'll know if you need to ask me any questions.
I'm not doing them in order. I'm doing the easy ones first, and go back to hard ones.
Okay.
Okay, so the first one is 4.5,
Yeah.
and the second one you should have gotten 250. All right, if you need help with those, ask me and I'll help you. If you got them both right, then you probably are getting the rest of them right. But at this time, I've noticed most people have the first two done. So I wanted to give you an idea if you're on target. If you need help, raise your hand. Make sure I come to you and give you some individualized attention.
I got 2.5 instead of 200.
Okay, so let me see where your mistake is. You're multiplying by 10. You got it. The 10's on top. When it's on top, you multiply. If it's on bottom, you divide. Okay?
Okay.
Does that help you out?
Yes.
Okay.
Thank you. Even though it's just last week, I never cleared.
It's not even with an Army.
But
Right.
you're gonna make fun of me.
I'm sorry.
But
It's absolutely
you just
not.
want to like, yeah, I'm not.
And my husband
If they, that's, but they want to like, yeah, I'm not. I know, I know it's all like, I
No, no, it's just. Wonderful.
Yeah, you're not gonna have your license. I'm not gonna start with
That's it. But Walker trained, did all these things. She's like, why is she on? I mean, she did a hard time. She's not. But I can tell you.
You still have that yellow.
But then she said,
Hey. I've heard they have.
Something you're in life. But it doesn't make anything.
Like.
Anyway, I just want to let you know, that's what we're doing with my life right now.
I got. Need to go.
And then I'm like, do I let her home? Do I let
It's hard. It's a triangle.
Joseph Darwin. So you can do the other one? Okay, let's go ahead. Let's do this. Okay, let me show you how to do this.
Oh my gosh. We're in the circus. Don't you have to do the other side too? Yeah, you have to do the side. It's number 5. At number 5, well.
Sure it is, right now. I am going to torture you. That's number 5. Since there's hours, you write hours. And how do you get that? No, not the second. I didn't. But now it's it's more about. And now the second. Now, after you've done that, I want you to do some also in your head. Try to draw it and if that's the setup, if it doesn't have the setup, it's the same for all problems. I was looking at it.
And now I'm thinking.
I was looking at it. This is how that's the process. So what you do, you hit, we're at 10 minutes space, and then 50 minutes inside. Okay?
But when they're.
Yeah, I'm going.
When they're
Oh, yeah.
already in so like you can't.
All right, let's go ahead and look at the rest of the answers, and then some of you may have some questions. I also know many of you are working very hard on the math side and have good chunk of your homework done, which is awesome. But here are the answers to the to that column. So see how you guys
Uh-oh.
did? Let me know if any of these you want me to do on the board. Yes. The last two on the board. Now, why am I able to do that last one? Are you not trying yet?
No, I got 50.
Okay, so.
Oh, I know what I did.
Then fix it.
So you fix
I know what I
it.
did.
Future reference.
And how many signatures? And then here, how many?
You can finish this ball. Come on.
Did you get your notes from yesterday? This one? Did your notes?
So like, if we need to do
That's not how it's remembered that on a test, I can't retell. So if I don't know what, you make a mistake and I don't know what the mistake's at, then it's either right or
So
wrong.
if we get it right, so and we don't have work, this is right? Okay. We get it wrong, then you can.
I can't.
Okay.
Okay.
I get the answers and scientific notes.
Okay, that's fine. I like I'm talking about. The main thing is just make sure you understand the process a little bit, because like when you go back, I do normal molecules. You probably can't do molecules in your head. Okay? Yeah,
I'm getting answers in scientific notes.
that is absolutely fine. So, but let's change your calculator. You want to change your calculator? So let's go to mode. And first off, let's get out of radians and go to degrees. So that'll enter. And let's see now. Let's see if that gives you point. I put it in time. 0.035 divided by 1,000. That took it off. So let's go back to mode again. See, it says normal, so let's hit enter. We want normal. First load. I don't understand why it's right here. This should be scientific and engineering. See what I'm saying?
Yeah. I think it just says it automatically.
No, it shouldn't.
I think they all.
Mine doesn't.
I'm right one second. Oh, and that's not.
Alexandra?
Yes.
Well, I didn't write that right. That's not right. I just put you number.
Like 5.
Oh, you're doing this side. Okay, and then don't forget that you have to take grams, centigrams, okay? All right. Ladies and gentlemen, did you pull out your thermometer paper? Pull out your thermometer paper. I did do this one just using 273 because that's what the key said to do on the top. The key said to use 273, 273.15. But if you use the 273.15, no biggie. All right, no biggie. Let's get good with the slide.
How do you convert kilograms?
How many grams does it take to make a kilogram? So you plug in 1,000 per grams and 1 per kilogram.
No, but
Oh, I told you.
oh, sorry, I'm not listening.
Okay, does anybody have any questions on the temperature conversion paper? All right. Yes,
How is -40 degrees Celsius -40 degrees Celsius?
just it's a coincidence. Total coincidence. It's the only number on there that's like that. So now you are officially smarter. And then if you'll notice off the side, 0 degrees Celsius is freezing and melting point, 100 is boiling and condensing point, and then 98.6 comes to his body temperature. So I thought you might be interested in that too. All right, on lab on Monday, one of the things you're gonna have to do in order to get a good grade is one, you have to do a bunch of conversions, but the other thing you have to do is be able to properly read your graduated cylinder. So what I need you to do right now is make sure that you can read a graduated cylinder. Yes, we can. I don't care.
I mean, I did it wrong.
Okay.
Okay, so one.
Do you have the right answers? Then you're perfect. Don't take that good. That's really bad.
Then think of there is.
Oh, how you know him.
Wait. Oh, yeah, that too.
All right. Now, there's two sides of this, and one side is just discussing about reading the graduated cylinder. Believe it or not, it's the toughest lab skill for you to learn. Most students are lazy about properly reading volume, and it actually screws up data. So what we need to do right now is we're going to spend right now looking at how you properly read volumes. We already talked about significant and insignificant digits. Remember, when you do a measurement, you have known that measurements, and every good measurement has a single watt also in it. We talked about it earlier this year. We talked about it. There's always a number that you know, and then one number you have to guess. And that's why your balance is always taking that hundredths place and doing what? What do you always notice that hundredths place doing? Because what's the balance trying to do? Guess the best answer for that one. Is that correct? Because even your balance is guessing that last digit. So what do we know? We know the ones place, we know the tenths place, but it's guessing the hundredths place is what it's doing. So we always have that. Now let's look at what we have here. And I just want to look at this picture first. Wait a minute, I forgot, because it doesn't come through very well.
Meniscus, what a fun word.
Okay, make sure you draw that one in on the mercury because it's hard to see. All right. Now, there are two types of meniscus. There is the concave and the convex. The most common version is the concave because what is most things made out of that we look at in the lab? What do I dissolve almost everything in to make my solutions? I use water. So most of the time when you're looking at something, you will see concave. If you had the honors of using a mercury thermometer, would you see convex? Unfortunately, we only have one mercury thermometer in the lab, and you guys aren't even allowed to use it because of all the new regulations on the dangers of mercury. It's just really sad because mercury is actually a lot of fun to play with, all right? But I'm not going to jail, so you guys are not going to play with it. Okay, so there we go, case closed. However, I frankly feel you're missing out a lot because I had a lot of fun playing with mercury when I was younger. So.
You mean you touched it physically?
Yeah, I tried. I put it on my desk.
What?
Yeah, didn't you? Did you have it? They have it on your desk?
We did it on my side.
So that's what's wrong with you.
So your mom, she did it too.
That's what's wrong with this entire generation.
All right. Hey, what was really sad is after we played with mercury, then we typically had our snacks. Because I think I did in like 4th or 5th grade. We still had snacks, and we wiped off our desk and they ate our snack on the same desk that we played with mercury.
And look, you're still breathing.
I know. I'm not really worried about it. But first off, what part, excuse me, fun. We're behind, ladies and gentlemen. We are really behind. This stuff that I did this whole first mod, everybody else did yesterday. Okay? So we need to stay focused. Okay, so this meniscus, what part of the meniscus are we supposed to read? And obviously it's showing you in the picture. It's very important that you pick up on that. Well, it's either the bottom or the top. It's always wherever the curvature of the meniscus is at. Is that correct? Now, the reason why you don't read the other part is on a 1-to-1, we have what we call basically a form of like electrostatic electricity, it's like electrostatic electricity, but it's not that, it's not electricity. But what happens is water likes glass. So if two things like each other, they're attracted to each other, is that correct? Well, because they like each other, it clings to the glass a little bit. And that's the reason why those are invalid readings when you read the curvature. So you have to make sure you're reading the bottom of the curve, not the sides. So it's where, like, anybody who wears contacts, it's like a little part that sits on your fingertip. That's the part you want to read. Not the part that goes up that makes it feel comfortable in your eye. All right? So make sure you're reading that. So what we're going to do now is we're going to look at some things. Now, a couple things to keep in mind when we are reading is what exactly are we reading? So I wanted to have you guys look at this little graduated cylinder. All right, and this is a nice 25 milliliter graduated cylinder, and it's really awesome because how is the little mark scaled on this? You go from 20, 21, 22, 23, 24, 25. So how is this nice graduated cylinder counting? It's by ones. So is that scaled so we can actually measure 21, 22? All right. So what we're going to do is we're going to blow it up because we only need to focus where the volume's actually at. And what do we know about this graduated cylinder? We know it hit 21, and we know it didn't hit
22.
22. So is 21 a known number? What's wrong though? Is 21 appropriate to write on the blank? Is 22 appropriate to write on the blank? So what do you actually need to write on the blank here? You need to read the bottom of the meniscus, and you need to take your best guess where you think that's at. So where do you think the best guess is there?
21 2/3.
I cannot take that.
Oh, 21.6 repeating.
Cannot take that.
21.75.
Still cannot take that. Now, do you know why all of those are wrong?
No decimals?
You can have decimals, but you can have that many decimals.
No.
Because I'm only good at guessing one decimal place.
Oh.
I know 21. And I know 22.
Then 21.7.
Now that's an excellent answer. Because I can guess up to one. Now, what were you going to say, Vincent? 21.8 would also be an excellent answer. We know it's better than a half, right? It definitely doesn't look like 0.9. Would everybody agree with me on that? So somewhere, I think 0.7 and 0.8 would both be perfect answers. You both would get full credit. Now, let's talk about significance. Is 2 and 1, 21, no numbers? And is my guess of 0.7 or 0.8 important to an appropriate measurement?
Yeah.
So is that 7 or 8 also significant?
Yeah.
How many significant digits would be in that number? 3. 2 that you knew and 1 that was a.
Yes.
So does the guess count in importance to the measurement?
Yeah.
Then it counts in importance and significance. All right, so flip your paper over. And I want to look at the very first one. And I'm using this one. Now be careful on this one. This one's a little deceiving because how is this one counting? Did they expect something weird about this guy? He's cut backwards. That's because this guy is. This guy is dispensing liquid. If he's dispensing liquid, we're not measuring the amount of liquid present. We want to measure how much liquid went out, which is why it's counting backwards. So we don't care about how much liquid's in there. We're concerned with how much liquid we just removed. But that's okay. Now, what is the eyeballs trying to tell me? Why do I have these eyeballs on here? They're on there for a purpose. And they're part of learning how to read a graduated cylinder. In this case, it's a barrette, if you're curious what you're reading. Yes.
Just guessing, but maybe like the different ways you look at it, it could be different measurements.
Very good. So what's this trying to tell you? What way should you look at it? Straight on. Because if you're looking down on it, it may make it look bigger. And if you're looking up, it may make it look smaller. We need to look straight on. So now, here's the problem. Some of wanna pick your graduated cylinder up and look at it. Why is picking it up a bad thing? Yeah, we're not good at holding something straight. You guys know that. You're gonna have to hold something in the back of the car and hold your best friend. Okay? We're better than that, but we all wiggle, all right? So you have to like, so now, if you're short like me, we're at an advantage. Because graduated cylinder is basically out of my eyesight. You tell people, you actually have to bend over. Okay, so just so you know, you might have to get in line with your graduated cylinder. Okay. Also, sometimes it's hard to read it. Feel free to take a piece of paper and put behind it, especially when we're working with colored liquid, because it's sometimes hard with the glares and different things. If you put a piece of colored paper or white, even a white piece of paper behind your graduated cylinder, does it make the numbers show up a little bit better for you? All right, just give you some contrast. All right, now this one here, then we already know it's 19.7. Now, why is the 0 important? Why couldn't I just leave it 19.7? Why do I have to have that 0 on the end, Alexandra?
Because there are 3 known significant digits and we have to guess another, so it would be 4 significant digits.
Right, and what is saying 0? What does 0 tell me?
It's saying that it's no more than 19 point this and that.
Okay, correct. But even more importantly, doesn't that mean you think it lands on the line?
Yes.
That's all I mean, what you said is correct. So I was helping out, but I was even looking for something. You were being excellently detailed. Okay. All right. So good job. All right. This one here is also dispensing. This one here is also dispensing. How is this one counting? And it's a little hard to see because it's really dark up here. Even if I turn the light on, help at all? I just don't think it does. But if this is 21, and this is 20. What does each one of these lines represent? You guys see that? They're counting by one. Is it counting by ones? Is it counting by 0.1? It is counting by 0.1. So this one is 0.1, 0.2, 0.3, 0.4, 0.5. So we're not only counting by ones here, we can actually count this one by tens. Okay, so what do you think this is measuring? And we are dispensing again. This is another dispensing one. Can anybody take a ventured guess on what this one might be? And if you think you've got an idea, just put your thumb in the air. Now remember, you're reading the clear part. We know it made it to 20. We know it made it to 0.1. We know it made it to 0.2. We know it made it to 0.3. Did it make it to 0.4? Okay. Trey, you've had your hand up this almost entire time. Would you like to tell us what you think the answer is?
20.38.
20.38. I'm perfectly fine with that. Does anybody want to put a different guess? I'm also fine with that answer. I don't think, maybe 0.7, but I think it's closer to 8 and 9 than it is to 7. All right. I probably would take off for 0.7. Now, how many significant digits would that be? If it's 21.38, how many significant digits would that be? 21.38. That would give you 4 significant digits. 3 you knew, and 1 was a guess. All right, now we're moving to graduated cylinder. It's nice about this one. It's nice and light, copied well. We can read it really easily. This is actually now reading the amount in there. What do you notice about the scaling now? It's going from smallest to largest. So we know now we're measuring the volume, not dispensing. So anybody like to take a guess at what this one says? Well, first thing you have to do is ask yourself, how's it counting? By ones. No, it's true. And then where's your guess? All right, put your thumbs up if you think you got it. You don't have to answer if you put a thumb up. If you put a thumb up, you don't have to put it in. I just know that your brain won't. All right, Abram, you were, I think, the first person to put their hand up. Do you want to answer it?
23.0.
You want to try just a different starting number? You said 23.
73.
73.0, I really like it. And I know that you knew the right answer, that's what I said. All right, 73.0. What was significant about him saying 0.0? Shows it's on the line. Yes?
Can I just write 73 because it's mathematically the same thing?
Absolutely not, because is the 0 important?
Yes, but.
Why is the zero
assume
important?
The zero's there.
Okay, we're not in math class right now, we're taking a measurement.
That's fair.
And in a measurement, do I need to know exactly where your guess is at?
Yes, it's.
And if you don't say the zero, do I know what your guess is?
No,
That's why it's important,
that's it.
okay? All right,
No, even though you just didn't round.
okay, again, I'll try to blow this up so you can see a little bit better, but I know you have it on your paper. How is this one counted? How's this one counting? By one, is that correct? Okay, so what guess would you have for this one? 36.5? Does anybody have a different guess? How many of you think Vincent's pretty dead on? I do too. I can see 36.6 maybe, but 36.5 is what I would bring, all right? Now let's go to a little harder one. First off, I want to make something very clear.
Why did she say it? Oh.
Okay, I have a question for you. What's wrong with this for measuring? Why is this a bad, what's wrong with using a beaker for measuring? Yes,
Beakers are not really precise. They're accurate.
they are not accurate at all. So let me ask you a question. Why ever have you measured using a beaker? Never, no. But for the purposes of significant digits, can I use it for a lesson on significant digits? Okay, how is this guy counting?
Straight tens.
Like 10. So what's the best measurement I can read? Paul?
40 point, I'd say about 40.4.
And I'll be careful on that. Do I
No,
know 40?
no. Yeah, we have 40, but we
What
don't,
one are you guessing?
no, wait. 40,
You're correct about 40. But what are you guessing?
we're guessing that decimal.
Or are you guessing the ones place?
Oh, I'm getting the one, like, you know what I meant.
I know. So what would be your answer? Not 40.4, would it be? Would be 40 what?
40, I don't know what you're getting at all.
You did, are you guessing the tens place or are you guessing the ones place?
Tens place. Oh, the ones place, so it'd be 44, oh,
It's just 44. No, it's okay. You see what I'm, now that's a common mistake. A lot of people want to guess the tens place because what are you used to guessing? But you're not guessing the tens place. This time we're guessing the ones place. So 44 is an acceptable answer. Is
Thank
that
you.
correct? All right. Try the next one. It's very similar. I apologize, it's so dark. It's not so dark on your paper, but it's dark up here on my screen. I think you guys can read easier on your paper than I can read on mine. Again, how's this one counting?
Do you think maybe you could put the lights out, it'd be easier to see?
I know, but it makes me tired. So what are we counting by this time? Tens. All right, put your thumbs up if you think you have a reasonable guess of the measurement. All right, now raise your hand if you want to try it. All right, Parker? 40. I like 48. Anybody pick a different number? I like 47. So we're going to pick, I think both of those are reasonable. All right, I wrote 48, but both of those are reasonable. All right, now wait a minute. What happens when you move to the next graduated cylinder? What happens when you move to the next graduated cylinder? How's this guy counting? So the only thing you know for sure is that you hit 2,000, you never made it to, which is why we don't use these for measuring. However, what would you say is a reasonable guess at the amount of liquid present? 2,600. What do you want to say? I like that one too. All right. All right. Now here's a tough one. What's wrong with this? Why is this one a really hard one? Doesn't hit any instrument. We know it's bigger than 0. And we know it's less than. So is there any no significant digits in this measurement? But what would your guess be be for how many hundreds are in there. So American 800 are both right answers. But let me ask you a question. Is any of those digits known? So it's only one significant digit, and that only digit is a yes. Please keep in mind, these zeros don't count, because are those zeros measurements, or are those zeros just giving us an estimation of the size and volume? All right, so they don't count. All right, how many of you feel better about how to read a graduated cylinder now? And now you realize some things measure up and other things measure down. If they're measuring down, they're not actually measuring the amount of volume, they're actually measuring how much is what? What do you call the little thing that you read inside the graduated cylinder? A meniscus. And what part of the meniscus do you read? Okay, very good. All right, put that aside. I do have a homework assignment for you the weekend. It takes you 5 minutes. We'll take you too long. I'm not done.
Yes, so it's not
Yes,
gonna be
no.
for everyone.
But we're trying to follow. But I don't want to give class after homework, because I'm afraid of what I'm talking about.
Not the homework was the next slide, Dad.
It is. Okay. Then remember, that's catch-up work.
Okay.
Because that's the work everybody else did last night.
Gotcha.
And then this one's just practicing, one side's thermometers and one side's graduation.
Thank you.
Yeah, this is homework fault.
Okay,
So, right
I'll
there.
do it.
Yeah.
Thermometer works.
All right, now we're going to take some notes. Oh, let me give you a clue on something. Unless it states otherwise, all volume is in what unit? Milliliters. And if it doesn't state otherwise, what is all temperature in?
Degrees Celsius.
Because with your measurements, you have to include the unit. So anything that's a graduated cylinder, what do you write after it? Milliliter. Anything that's a temperature, what do you write after it? Unless it states otherwise. However, we're slowly but surely getting caught up.
Good.
Extras, just send it back down. And then don't forget, what did I say is the unit on all of these, Paul?
Unit
Degrees Celsius.
is Celsius.
And then on the other side it is, no, milliliters.
Oh, great.
Okay. Oh, Vincent, this is for reminding me to do your papers. There you go. All right. Now, what we're going to do next is we're going to take notes on the side that says 0. I'm sorry. Significant digits. All right. I'm going to blow it up. I'll blow it up so you can see these two a little bit better. At this point, though, I will turn the lights off for you because I do know you guys like to read the notes better in the dark. So if you want to turn the palm tree light on, feel free to do so.
Ooh. Cool.
All right. That gives you guys at least a little bit of light over there to see your papers. Oh, sorry, did I miss you? All right, sorry. All right. Significant figures. Now, here's the good thing. I have spent a lot of time discussing significant figures, and you should already know where they come from. They come from what? Where are they derived from? They're from measurements. The reason why significant digits came into play is you're only as good as your weakest measurement, all right? Now, of course, in athletics, we always say you're only as strong as your weakest link, all right? In math class, you're only as good as your weakest measurement, all right? Significant figures came from measurements. Well, why is this so big in a science class? And what do we do a lot of in science class? We take measurements. But I've already helped you with this. You guys already know the answer to this question. You already know that all measurements are made up of known values and one good what? Yes. Is that correct? Now we're just going to look at it from the standpoint of actual digits and what happens with the number 0. All this one to the left, and we're gonna do the non-zero digits.
Yeah.
All right, the non-zero digits, these are the values 1 through 9. And anytime you see a number 1 through 9, what do you know about them? They're always significant.
How come zero isn't?
That's what we're gonna spend the rest of the time talking about. Because sometimes 0 is a value, and sometimes 0 is a placeholder.
Yeah.
And when it's a placeholder, it is insignificant. And it can be a placeholder in the front, and it can be a placeholder in the back. All right, let's move to the one to the right. And let's talk about the digit 0. I did a better job on this flow chart than I did on your last one.
I love that word, zero.
I know, last night I went to a choir concert with my daughters and they sang 0 to hero, or is that how it goes, 0 to hero? And I made me think of, oh, that fits my lesson. I should have that as a theme song today. Yes,
Which school do your daughters go to?
Jackson.
Jackson? Okay, I could use that as a critique.
All right, everybody okay with this one? Now, what I'm gonna do is I'm gonna go across the bottom, and we're gonna talk about, there are 3 places a 0 can be. One of the places a 0 can be is a leading 0. That means it comes in front of a number. All right, that's typically like 0.003, one of those deals. It's when 0's in front, we call those leading zeros. They are never significant. So if the 0's out front, do they ever count as significance, or are they just placeholders? Believe it or not, they're just placeholders. So anytime you see a 0 sitting in front of a number, and what do I mean by a number? I mean a digit 1 through 9. So anytime you see 0s sitting in front of a number, and what I mean by that is any digit 1 through 9, they're insignificant. They're nothing but placeholders.
Would a leading 0 be when, on a graduated cylinder, whenever you're measuring it, it doesn't get to 1, so it's no.
So that first digit is not significant, the 10th place would be.
Okay, so it's still, they're not going to be 0.
There would be 0.8, right? The 0 would be insignificant, but the 8 would count. And the only one that would count would be your guess.
Yeah.
Okay, does that help you out?
Yeah.
All right. All right. What's the next type of 0? It's the confined 0. And I did give an example. Confined means, in other words, you could use the trapped 0. The 0 that's between 2 other digits. So if a 0 is trapped between any other numbers, then they always are significant. All right? They call them the confined zeros. You could call them the trapped zeros if you want. Zeros, and they're weird. They're all over the place. Sometimes they count, sometimes they don't. All right. What is the key factor on whether they count or not? It's the decimal. The decimal is your ruling factor on this. We'll talk about it here in a second. I have a bunch of examples for you to add to this one.
This one's not.
Yeah, I did. Yes.
In a minute, I want to scoot it over, and I have some examples off to the side. When a trailing zero counts and when a trailing zero doesn't count. And I'm also going to give you an example of these over bars, okay? I'm going to show you what that means. There's probably many of you have never seen them before, so I just want to show you what those are talking about. And I have some examples off to the side here. So what I did is I gave you the exact same number, the exact same 5, with the exact same number of zeros. So this is 5, comma, 0, 0, 0 with a bar. 5, 0, 0, 0 with a decimal. 5, comma, 0, 0 with a bar. 5, decimal, 0, 0. 5, comma, 0, 0. And we're looking at the number of significant digits that each one of those represents. If you see a bar, everything counts to the bar. The one after the bar does not count. So that's 3 digits. If there's a decimal, the decimal makes all the zeros before it and all the zeros after it count. As long as there's a number present. As long as there is an actual number 1 through 9 present. This one's got a comma because they put a bar over it, all of them count. Again, I put the decimal here after the 5, and those zeros still count because there's a decimal. Here, I put a comma but no bar, so what's the only digit that counted?
5.
It was the 5. The bar is showing me where significance stops. That's what it's for.
That's cool.
All right? Now, what I just gave you is another piece of paper. And what I would like to do right now is I would like to do the first 5 with you, and hopefully you guys can do the second 5. It's not homework. I just like to go through it and see how many significant digits each one has. Now, what did they tell you about leading zeros? Do they ever count? Do leading zeros ever count, or do they never count? They never count. We cross those out, and there is 1. Question number 2, do the leading zeros count? But why does this trailing zero count? Because of what? The decimal. So these two don't count, this one does. So how many significant digits are there? This one's a trap zero. What do you know about trap zeros? So there's 3. Here's a decimal. The moment there's a decimal, what does that do to all zeros after the number? They're significant, so there'd be 4. But this one's a what, guys?
Why is there only 2 on numbers 1 and on 2?
Because leading zeros never count.
Oh.
In your notes, leading zeros never count.
Oh, I forgot.
Okay? Now, this one's a comma. So what does that do to all these trailing zeros?
They don't count.
They don't count, so it's only 1. All right, what I would like you guys to do, and this is all for the going to get until the bell rings, it's 11:32. I would like you to try 6 through 10, and I'll put the answers up. And that's all for they're going to get. I can leave, just want to run over and grab the other.
Nope. Okay, I got a little quick while he's working on that.
Okay.
He just needs support this week.
Yeah.
Much better though than St. Paul.
Thank you.
Right?
Yeah.
Raise your hand, put your thumbs up when you get them done, so I know. So I know it's not gonna take people a whole long time to do it. All right, can we yell them out? Can you guys just go through them and yell them out? How many significant digits are in 6?
4.
Correct. How many significant digits in 7?
6.
How many significant digits in 8?
1.
How many significant digits in 9?
3.
There is 4.